Question number 42. This is GATE 2009 question. It's a very tricky question. Very less data is given in this question. Generally, student will be confused by this question. In this question, instead of given data, also we need some extra data we need to remember. We will see first what is the question. In an N-type semiconductor crystal, silicon crystal, at room temperature, which one of the following can be have concentration of 4 into 10 power 19 per centimeter cube? Is asking that he given that it is a N-type semiconductor, N-type silicon, and room temperature, and concentration is given. Generally he asked the concentration, but he given the concentration. What is that concentration is? Silicon atoms, holes, or dopant atoms, or valence electrons? So we need to find what is this value. So he given that N-type silicon and room temperature. Given N-type semiconductor and room temperature, and this concentration is 10 power 19 per centimeter cube. Now from this data only we need to bring the required answer. Given is N-type semiconductor. So for N-type semiconductor of silicon, also silicon, for silicon intrinsic carrier concentration is equal 1.5 into 10 to the power 10 per centimeter cube. And from this room temperature, at room temperature, if it is N-type, number of electrons is equal to number of doping atoms. Either if it is P-type, number of holes is equal to number of acceptor atoms. But he given the only N-type, he given the only N-type, so ignore it. Nd, number of electrons is equal to number of doped atoms. And at room temperature, mass action law will be satisfied. N into P is equal to number of electrons into holes is equal to Ni square. From this, we treat this given as 4 into 10 power 19 is more than the intrinsic carrier concentration. Intrinsic carrier concentration is 10 power 10 only, but he given some concentration of the carrier is 10 power 19. So we will treat given concentration is number of doped atoms, means Nd. Nd is equal to 4 into 10 power 19 per centimeter cube. From this data, from this equation 1 and 2, Nd into P is equal to Ni square. So number of holes is equal to Ni square by Nd. We know the Ni value is 1.5 into 10 power 10 into 1.5 into 10 power 10 whole by Nd value 4 into 10 power 19. By doing the calculations, we will get the answer is 5.625 per centimeter cube. This is our assumption is true. What is our assumption? Given concentration is doped atoms, number of doping levels. So what is the P? Number of holes. Number of holes is this. By seeing number of doped atoms means number of electrons is equal to 4 into 10 power 19, and the number of holes is equal to 5.625 only. By seeing this, N is greater than P. Therefore, this is N-type, so number of electrons are majority carriers, correct. P is the minority carriers. So the given data is number of doped atoms. So number of doped atoms is correct answer. Number of doped atoms means number of free electrons. How many of atoms are present, that much of electrons will be formed in the silicon. Therefore, electron will become n-type semiconductor. So our answer is dopant atoms. First of all, given the n-type semiconductor, for n-type silicon, intrinsic concentration we need to know. From the room temperature, N is equal to number of doped atoms. From mass action law, this one is from mass action law. So just by substituting all the values, we will get the P is very less compared to the N. So given concentration is doped atoms.